Okay, another type of naming that we had was called aromatics, and there's three possible types. The first one is if they're all single bonds, we use the prefix cyclo. So in this case, I have 1, 2, 3, 4, 5, 6 carbons, so this would be called cyclohexane. They're all single bonds, there's 6 of them, and it forms a cyclo structure. Same with this one, I have 3 carbons, so it's a prop, and it forms a ring, so cyclopropane, cyclopropane, and my last one here is cyclobutane because I have 4 carbons all single bonded. If we have groups coming off of our cyclo rings, if we have these branches here, these are both methyl groups. So we would name our parent chain basically the same way that we would name a regular chain, but in this case we have a ring instead. So I would label my carbons with the lowest possible orientation. I have 6 of them. And the groups of the methyls are at 1 and 2. So I would say 1, 2 dimethyl, just like we did with a regular chain. And then because it's a ring, I would say cyclohexane. That cyclo has to be added to say that they're all in a ring structure. Here I have 4 carbons, so it is a butane, a cyclobutane ring, but I do have an ethyl group as a branch coming off of the ring. I'll just label that as carbon number 1, and if it's at carbon number 1, we don't have to include the number if that's the only thing on the ring or the chain. It is in this case, so I can just say ethyl cyclobutane to name that one there. If we were drawing from a name, drawing the structure, I can see cyclopropane is my parent chain. So I'm going to draw a cyclopropane that looks like this. Prop is 3 carbons. I can label those as 1, 2, and 3. It doesn't matter whichever way you want to label it. On the second carbon, there is a methyl group, so that would look like this. For our last example, I have a cyclohexene in this case, so I have an ENE ending. So I can draw my cyclohexane first. This is all single bonds, and I can number my carbons up to 6. And then drawing in, it tells me I have on the second carbon, I have a ENE ending, and that means that I have a double bond on the second carbon, as well as an ethyl group on the third. So we remember ethyl has 2 carbons, kind of looks like that. So that's your final structure. The second type of aromatic is if we have a benzene ring. So remember the first type, they were all single bonds. We know that if we have a benzene ring, it has double bonds, and that's how you know it's a benzene. So you can see benzene either drawn like this with the double bonds, or sometimes it just has a circle in the middle, meaning that the double bonds are rotating around the structure. So those mean the same thing, and it represents a benzene structure. It's always going to have 6 carbons. And so we have 2 possibilities in our first example. We have the benzene ring as the parent chain, and we have 2 methyl groups coming off of the parent chain as branches. So we label those as we normally would. That's a 1 and 3 dimethyl benzene. So we have our locations as 1 and 3. I could go around, draw to 6. So that's where those locations are. We have the di to tell we have 2 methyl groups, methyl and benzene. I'm just missing the L there, methyl. Second example, I do have a branch. It's an ethyl group, and that's coming off of a benzene chain. So I can just call this ethyl benzene. It's at the first carbon. It could be, you could number any of them as number 1, so we'll label that one as number 1. If we were given some names, we had to draw them. I'm going to draw my parent chain first. In this case, my parent chain is benzene, so I'm going to draw that first. It's always going to look the same. I personally like to do the structure with the double bonds, but you can do the circle if you would rather. On the second carbon, there's a propyl group. That means we have 3 carbons in this group. We also have an ethyl group on the first carbon, and that looks like this. And that's your final structure. Last one, propylbenzene. I am going to draw my benzene ring. Could do it like that. And I have a propyl group. It doesn't indicate the location, so it must be on the first carbon. and propyl means 3, so I've got a structure that looks like this. So this is the type 2 when you have benzene as a parent chain. Your type 2 extended, something to keep in mind. If you have a 1 and 2 orientation, so like we've drawn before, we would say this was our example. If we had a methyl group at location 1 and 2, we could name it 1,2-dimethylbenzene. However, there's another orientation you may see in your homework or in some of the assignment questions or in future, so I want you to be aware. If you have groups at 1 and 3, you can substitute, instead of saying 1,2-dimethyl, you can substitute in this word ortho, and that indicates that you have the groups at 1 and 3. It would still be ortho-dimethylbenzene. Sometimes they write it with just an O-dimethylbenzene. That's the same thing as 1,2-dimethylbenzene. So one of the questions in your homework says ortho-ethylpropylbenzene. And so if we were to draw that out, I would draw my parent chain first as a benzene ring. And they're telling me the two groups ethyl and propyl are in an ortho orientation. So ethyl would be CH2CH3 and propyl would be CH2CH2CH3. So ortho indicating they're at a 1-2 position. If we do have a 1-3 position, we can call this meta. So we don't have to label the 1-3, we can just assume it's a meta position. So if we look at our example, I have 2 methyl groups on carbon 1 and carbon 3. And so this is located, it could be called 1,3-dimethylbenzene, or our new name could be meta-dimethylbenzene. Sometimes, again, they label it with just an M and say M-dimethylbenzene. All 3 of these names are the same. So if we were to give an example that were, say, M-methylpropylbenzene, I would start by drawing my parent chain. In this case is benzene. So I know it's going to look like that. They're telling me I have 2 groups attached to this parent chain, a methyl group and a propyl group. Well, what orientation, where do I draw them? This M tells me the methyl comes first on the group 1 and the propyl is on the third. So CH2, CH2, CH3. Whatever group comes first would be my location number 1 and the second one would be location number 3. The last thing to keep in mind for the orientation for benzene, you could also have a 1,4 position. So if this is, of course, you'll notice we only have 2 groups each of these times. If we're looking at ortho, we have 2 groups, meta 2 groups, and para is our last one. So you can only use these orientations if you do have 2 groups. The first one is 1,4, and so this is our para orientation. If we have 2 groups at 1 and 4, you could name them 1,4-dimethylbenzene like we did before, or now you can name it para-dimethylbenzene. Again, just using a P indicates the same thing, so all 3 names are the same. So if we were given this example, para-methyl-ethylbenzene, I'm going to draw my my benzene group looking like this, and I have a para position of methyl and ethyl. So methyl is going to be drawn first, and ethyl is going to be at the 4th position. This is a CH3. And I can say this is now a para orientation. The third type of aromatics is when the chain is longer than the benzene, and so your parent chain therefore becomes something on its own, and the benzene acts as a branch, basically. Your key here is when benzene is treated as a branch, it's now called phenyl. So it's a phenyl group instead. So sometimes if you see benzene, you might automatically think, okay, I need to label it as a benzene labeling system, like we just did with our ortho, para, meta, and so on. But that's not always the case. It could be acting as a branch, and we would label it as phenyl. So if this was the case, you can see I've got some examples here. This is usually when the parent chain is longer than 6 carbons. So if it's longer than the benzene ring, the benzene becomes a branch. Sometimes that's not always the case, but normally it would look like this. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons. This chain is longer than my benzene chain, so I have 2 branches now. I have a methyl group here, and this benzene is going to act as a branch. When it's a branch, we call it a phenyl group. So in this case, I do have to label my branches alphabetically. So methyl comes first. That's on the second carbon. Then I also have a phenyl group on the first carbon. Oops, I spelled that wrong. On the first carbon, so I do have to indicate that location. And then my final parent name is octane. Remember, we have all single bonds, so it's ANE. For the second example, I have 1, 2, 3, 4, 5, 6 carbons. Remember, you could label it in the other direction, but we want the lowest numbering system. So this gives us our phenyl group on carbon number 3 instead, and that's lower, so we label from the left in this case. So we indicate where our phenyl group is on the parent chain, and then we give the name of the parent chain, which is hexane. The last example is from your homework. It is 4-propyl 5-phenyl octane. So I start out by drawing the parent chain, which has 8 carbons on it. 1, 2, 3, 4, 5, 6, 7, 8. And I have a phenyl group on the 5th carbon. So I like to number these so that I can see exactly where I need to draw things. My phenyl group is on the 5th carbon, so I'm going to draw a benzene ring on that 5th carbon, and on the 4th I have a propyl. Remember, we want to try and draw them at the top and the bottom separated as much as possible, if we can, to avoid some sterics. So fill in the rest, and that is your final structure. The last part for the assignment that you needed to know was halides, and these are just halogen groups that come off the parent chain. So our halogens are the chloro, fluoro, bromo, and iodo. These are our halogen groups, and we can find them as branches on the chains. So if this is your chain and you have a chlorine group on the 2nd carbon, we can see this is 1, 2, 3, 4, 5, 6 carbons long. I would say this is 2-chlorohexane. And if we have multiple, we use the same rules. So here we have 1, 2, 3, 4, 5. I have a bromo group at 2, 3, and 4, tribromo, and pentane, showing we've got 3 bromo groups and our pentane is 5. And the last one, or second last one, we want to number in the lowest numbering system. This one starts from the left. I do alphabetically, so on the 4th carbon I have a bromo group. On the 2nd carbon I have a fluoro group, and then my parent chain is heptane. If you had a triple bond or a double bond, you would have to indicate the location. Just like in our last example here, we have 2,3-diiodohex-3-ene. Sometimes the 3 can be shown before the parent chain to indicate where the double bond is. Sometimes it's right in the middle in this case. So I'm going to draw hex, meaning 6 carbons, 1, 2, 3, 4, 5, 6. On the 3rd carbon, I have a triple or a double bond, ENE. I also have an iodo group, an iodine, on the 2nd carbon and on the 3rd. That's everything that the name tells me, so I can fill in the rest of the bonds. Each of these carbons needs 4 bonds. The last thing to note is that if you do have a group like this, it'll be actually more so common on a benzene ring. If you have an NO2 group coming off of a benzene ring, so something that looks like this, we name this a nitro group. So you would name it the same way as you would name everything else. This would be nitrobenzene, assuming that this is carbon number 1.